Assalamualaikum and welcome to all. My name is Eleni and I'm excited to take you through this presentation entitled Geometric Grace, Redesigning Arabic Calligraphy using Wang-Ball curve. So let's dive in. By the end, you'll walk away with a deeper understanding of this presentation. Let's get started. First and foremost, let's start with a quick introduction to our team. Our project came together through the efforts of 5 key roles that are Suziana Aida, Nur Elini, Siti Najwa, Nur Aisyah, and Nurul Izzati. Here's an overview of what we'll be covering today. Let's begin with the introduction, where we'll cover the background and explain why this topic matters. Arabic calligraphy is one of the most respected artistic traditions in Arab and Islamic cultures, recognized for transforming the Arabic script into visually and spiritually meaningful art. The aesthetic principles is defined by precision, balance, and proportion, crafted using column, fine ink, and quality paper. This craftsmanship also influenced the development of Jawi, a derivative of Arabic script used to write the Malay language. This project introduces an innovative computational approach to redesign Arabic calligraphy using Wang-Ball curve, a mathematical model from computer-aided geometric design (CAGD) principles. This project aims to digitally reconstruct Arabic antiphons using the word iman as a chosen subject with mathematical accuracy while maintaining its artistic essence. This integration of art and mathematics demonstrates how computational methods can preserve and modernize calligraphy, positioning it as both a cultural heritage and a medium for technological innovation in the digital age. Now, let's take a closer look at the core problem we are addressing. The first one is the cultural gap. Current digital tools fail to capture the subtle geometry, smooth curve, and proportional accuracy of traditional Arabic and Jawi scripts. Second is preservation crisis. This limitation restricts the ability to preserve, disseminate, and innovate upon these scripts in the modern design, education, and cultural applications. The third one is innovation need. A computational approach is needed to bridge traditional artistry with digital precision while maintaining cultural authenticity. Understanding the root cause helps us see where the change was needed. The first goal is to blend the timeless beauty of Arabic calligraphy with the precision of modern mathematics, reviving Islamic art through digital innovation while preserving its cultural and spiritual soul. Second goal is to redesign Arabic calligraphy using the Wang-Ball curve, and the third goal is to analyze curve degrees from 2 to 4 for accuracy and smoothness. After setting the goals, we needed a clear step-by-step approach to turn those goals into real results. There are 5 steps. The first step is doing the manual sketching to produce curve points. We choose the word iman. Second is formulating equations, which developing Wang-Ball curve equation for 2, 3, and 4 degrees. The third is writing instructions to code all the curve into MATLAB software. The fourth is generating the digital iman calligraphy for 2, 3, and 4 degrees. And the last is analyzing and determining the most accurate curve degree. As we choose the word iman in this project, the iman calligraphy as shown in first figure was used as a subject. Then this calligraphy was replicated on graph paper to locate the curve data points as shown in the second figure, and then sketched with control points as illustrated in the third figure. The next step is to formulate the Wang-Ball curve for degree 2 until degree 4. So the equations are as follows. Then the instructions for coding all curve into the MATLAB software is done. To write the instruction for coding all curve into MATLAB software, the formula derived in second step for each degree will be used. If there is no error, the process will proceed to the next step, step 4, and the iman calligraphy will be generated. Wang-Ball curve use a set of control points to define their shape. The exact formulation of Wang-Ball curve involves specifying the position of these control points. For example, a degree 2 Wang-Ball curve has 3 control points, a degree 3 Wang-Ball curve has 4 control points, and a degree 4 Wang-Ball curve has 5 control points. Values of these control points influence the curve trajectory, and modifying them alters the curve shape accordingly. Then, the iman calligraphy from degrees 2 to 4 was generated using the Wang-Ball curve. The iman calligraphy is made up of few different curves as illustrated. The next step is to compare the curve. This figure shows the combination of all degrees of Arabic calligraphy from the word iman. As a result, the best iman calligraphy was curve was determined. The green color represents the curve of degree 2, the red color represents the curve of degree 3, and the blue color represents the curve of degree 4. Here comes the results. Based on those figures, it is observed that the curve generated by degree 4 offers greater accuracy, attributed to its increased number of control points compared to the other degrees 3 and 2. The hypothesis posits that higher quantity of control points correlates with improved accuracy. More specifically, degree 4 is identified as more accurate than degree 3, which in turn surpasses the accuracy of degree 2. And this is the results for the computation time. Now, here is where things get interesting. The novelty of this innovation lies in using the Wang-Ball curve to digitally recreate Arabic and Jawi calligraphy with greater smoothness and precision. Using the word Iman as a case study, the results showed that higher curve degrees produce calligraphy closer to hand-drawn work, with degree 4 offering the most authentic look. Additionally, it uniquely combines mathematical modeling with traditional art, preserving cultural authenticity while opening new possibilities for education, design, and modern digital applications. Having developed and refined our solution, it was crucial to understand its potential impact. We explored the market potential to see who could benefit and how significant this opportunity is. Based on the user perception survey conducted among 40 respondents, the findings show a strong interest in adopting digital Arabic calligraphy technology. These results also demonstrate that users value both cultural authenticity and technological innovation, suggesting that the Wang-Ball curve-based calligraphy system has strong commercial potential to appeal to diverse user groups, particularly in fields such as education, digital design, and Islamic art production. This project has strong potential to move from research into practical use. It can support digital font and typography development, creating authentic Arabic and Jawi font as tools or plugins for platforms like Adobe Illustrator for iDraw or Microsoft Word. Looking forward, it could also evolve into mobile apps or AI-powered tools for personalized calligraphy in greeting cards, fashion, digital art, and more, creating niche markets and licensing opportunities with design companies and online creative platforms. As we close, I want to highlight the success of our project, the digital construction of the Iman, where we validated the relationship between curve degrees, smoothness, and precision. We also recommend that future researchers compare this approach with Bezier, B-Spline, and others. And last but not least, our project Geometric Grace successfully bridged tradition by transforming Arabic calligraphy into dynamic digital art form. Thank you for listening.